What's going on YouTube? This is Ipsec, and we're doing Boardlight from HackThebox, which is a nice, easy machine because really, it's just some enumeration and two CVEs with public POCs that work out of the box. So if you want to solve the box, nothing is too technical. That being said, we will be digging into both of the exploits, so this video may make it appear harder than it is. It starts off with some virtual host enumeration to discover Dolibarr, which is a web app that enables people to create their own websites. There's a filter in place that prevents those users from executing PHP, but it's case sensitive, so it's pretty easy to bypass. Then you can run PHP code and get a shell. From the shell, you can read the web config that reveals the MySQL password, which is also the password to one of the users on the box, so you can switch to that user who can execute a SetUID binary that's part of the Enlightenment system, and it has a CVE that allows us to escalate to root. So with that being said, let's just jump in. As always, I'm going to start off with an nmap, so -sc for default scripts as v, enumerate versions, -vv for double verbose. This gives us the TTL and things like that. OA, output all formats, put in the nmap directory and call it Boardlight, and then the IP address of 1010.11.11. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open, the first one being SSH on port 22, and its banner tells us it's an Ubuntu server. We also have HTTP on port 80, its banner tells us it's Apache, also running on Ubuntu. So there's really not much information in this nmap, so let's just go take a look at the web server. So I'm going to go to 1010.11.11, and we get a page that just says, welcome to Boardlight. Now, the first thing I really look at when I'm looking at a web server is trying to identify what framework it uses. So we could first just try like index.html. We get a 404 not found. If we do index.php, we get a page. So we know this is a PHP web server. We could also hover over the links and we see they are going to .phps. We have about.php and do.php. And oddly enough, it looks like these pages are part of the homepage as well. So maybe index.php is just grabbing every page and building one big website, while each of these scripts are the individual thing. I'm not sure how it's working, but normally when I see these links up here, it's not individual pages, it's some type of anchor in HTML. And when you click it, it just auto scrolls your browser to that part of the website. So a bit odd there, but nothing too interesting yet. We do have a host name right here as an email address, info@board.htb. We also have board.htb here, and that link goes to html.design, which is a bit odd. But let's just go take a look at the board.htb website. So I'm going to go into my host file and do 1010.11.11 board.htb. So now I can tell my browser to go to this site, and we get the same exact website. So going to it over IP address or domain, it doesn't matter one bit. So at this point, we have to figure out what we want to do. We can either run like GoBuster and find other PHP scripts on the website. We can try to find where user input is accepted, which is probably going to be like this callback. So if we do ipsec, let's do a fake number. And let's see, test. Let's see if this sends anything, right? We'll turn intercept on. And actually, instead of just sending test, let's just do image source is equal to HTTP 10.10.14.8. We'll do on port 8000. And this way, if there's like a user getting this and it's vulnerable to cross-site scripting, they should make a callback back to us, right? So let's start up our netcat on port 8000, just in case that does happen. I did want to make sure intercept is on, turn BurpSuite on, click send. And if we look at the request, it's not sending a single thing. So the contact form just goes nowhere. So at this point, we just want to run GoBuster. We can either attempt to brute force file names or virtual host. I normally start with virtual host just because it goes a bit quicker. There's like less of them. So let's run that real quick. So we can do GoBuster vhost -u http board.htb wordless op seclist discovery DNS. We'll do subdomains. Let's just do top million 5000 and see if we get any hits, right? The first thing is board.htb. So let's add that to our host file. So sudo v etc host, and then we can add crm.board.htb. Add that. And let's take a look at this website. So we do http crm board htb, and we get an instance of Dolibarr. And I don't know what this software is, but it's very kind and tells us the exact version it's running. And whenever I see that, I'd always just search the software, the version, and then exploit. Let's turn intercept off and make sure this goes to Google. And we have a POC exploit right here. So it looks like we just give hostname, username, password, lhost, and lport. So we need to know the username and password for this Dolibarr instance. So let's just Google Dolibarr default username and see if Google tells us anything. If you did not change it, log in into admin and, admin right here. So if we try to log in with admin, we get logged in. So we should be able to now try this exploit out. So let's do a git clone on the exploit script. And then let's see, Python 3 exploit. We want the target host name. So we'll do HTTP, CRM, CRM board HTTP, username admin, lhost 10.10.14.8, lport, we'll send it to 9001. Okay. Send this. And it's going to create the site page and attempt a reverse shell callback, and we get a shell. Now, I don't like stopping at this just because I have no idea what just happened. So let's take a step and slow it down and explore what this exploit script is doing. So I'm just going to, let's go into the actual exploit, vexploit.py, and take a look at it. So let's see, we have the auth function, create site, and at this point, it's sending a lot of HTML in the request that I don't fully understand. So I just want to proxy it because I like looking at this type of stuff in BurpSuite. So to do this, we can easily just look for any request. And we have a request.get and a request.post and a get there. So we could edit to add proxies here. So we could, at the top, just say proxies is equal to HTTP and then HTTP 127.0.0.1 I think this would work, right? And then we go to where the request.get is. And then we just go to proxies is equal to proxies. And I'm not actually going to do it this way because I think it's a little bit of a pain to edit every single request, but I do want to show it, right? So let's go and run this again. And whenever it does that CSRF check, because that's the one request we had edited, it should go over here, right? But we're going to miss a lot of other requests. So what I would recommend doing in this type of case, if you don't want to go and edit the exploit script, maybe it's not in Python and it's just hard to edit, right? We could go to BurpSuite, go over to our listener. So proxy settings, and I'm going to add an interface. Let's add one on port 8081. And then, actually, I'll remove that because I forgot to click something. We'll bind to port 8081. And we're going to redirect it to the host 10.10.11.11, port 80. And let's see, support invisible proxying, enable only if needed. I don't know exactly what invisible proxying does. Let's add this and see. So we turn this on. And before we run the exploit now, we want to edit our host file. And I'm going to make 127.0.0.1 going to be CRM board HTTP. And I probably should delete it from here, but the host file is going to pick the very first one. So if I ping CRM board HTTP, it's always going to go to 127. So host file picks the first one. Probably shouldn't have multiple entries. I guess we'll comment it out. But there we go. So now with this exploit script, if I go to 127.0.0.1 port 8081, or actually if we do CRM board HTTP, that's not what I wanted. HTTP, CRM, board, HTTP, 8081. It goes over into BurpSuite. And we get directed over to Dolibarr, right? So if I log out. So this is a good way just to set up the proxy. So here, we just want to specify now 8081 on the proxy exploit script. So now the exploit script is going to make a connection to CRM board HTTP on port 8081, which is really our BurpSuite server. It's going to be able to examine that request and then forward it along to the Rio board server, right? So this is kind of a inline or transparent proxy, which just means there's a proxy there, but you didn't have to tell the client about it because the proxy is sitting on the wire and just doing the man-in-the-middling that way. So let's go and run this. And if we look at the request, we can see the first one comes through. We have a session ID. We hit index twice, it looks like there. Here we're getting index.php, setup not complete. I wonder if this is just the home page. I'm kind of curious why we're not sending a login request yet. Every request is coming twice. I wonder if we're making the request, it's directing us back, and then we're making it again not on port 8081. Is that what just happened? Here we can see we are attempting a login, right? So I'm going to forward this request. Setup not complete. Setup not complete. I'm not exactly sure why we are making so many requests, but okay. And then here we're making a post to website index.php, and the virtual host, I don't fully understand what's going on here. So I'm actually going to step away from the exploit script and do something we should have done. Log into Dolibarr and then identify what this application actually does, right? So going to admin, it does not appear to be loading. I wonder if that's because we have a request running. Let's just disable all that. I wonder if this is not like a threaded web server. That is bizarre. Oh, I looked here to discover, hey, I'm not proxying. I'm on port 8081. So I was proxying. Again, it's a transparent inline proxy, so your web browser doesn't fully know. And I can't actually go to the non-proxy address because it's pointed at 127.0.0.1. Okay, that all makes sense. Sorry if you're confused. I was for a minute there. Long story short, I was intercepting. I didn't think I was, but I was. So we go over to websites. We can create a website. So if we do a name, description, and then virtual host, it looks like virtual host must start with HTTP. So we'll do HTTP pwn.boardHTTP. Let's make that font bigger for you. And then we create our website. So we could clone a website and like pick a copy of a website, I guess, if we wanted to, or we can just like create individual pages. So here, this is probably going to be the other request it makes. We're creating a page. Page name and title is needed. So we send this request. And then it does something here to get code execution. I'm going to guess that we can just write PHP code or something, right? So if we do like PHP, I like always testing with PHP info first, or like an echo. But if we do PHP like this, and we can click save, it says you don't have permissions to add or edit PHP content on the site. Maybe we can do like PHP 5, save, and we don't have access. So let's just see exactly what the script is doing. If we go to HTTP history, or we probably should just intercept and go through the process again. So intercept on, run the script, forward, setup not complete, that's fine. Here we are logging in. Setup not complete, there we go. So this is the post to probably create. We have add container create, the website, and they're creating the virtual host of a random string.localhost. Then what they're doing is sending another request. And we're looking for PHP code. There we go. I think I did a hotkey to forward the request. I did Control F thinking I'd find, but I think it actually forwarded the one request. We got to a second one. And here they're creating a PHP string, but they capitalize one letter. So it looks like the check is just doing a look for PHP, but it's not case sensitive. So if we make it capital, we can then run PHP code. We could test that by going back to a browser and setting this, right? So let's go and save and stay. It says saved. We go over to websites. Let's see, here's this. How do we view? Probably this icon. It's directing us not through a proxy. And we get PHP info. So what we want to do now is get a reverse shell here. They use system and then just do a bash one-liner. I don't like doing that with PHP. I'd rather just copy the PHP reverse shell. I think it's user share lawnum PHP, this shell, because I find this shell to be a bit more reliable, right? And I know if you search ipsec.rocks, you'll find an even better one that actually supports Windows 2. I can't remember the name of that shell off the top of my head. So actually, I'm going to pause the video. We're not going to use this one. I'm going to find out exactly where the reverse shell that also supports Windows is, because that's the one we probably should be using nowadays. Okay, I found it. If you want it, you can go Google PHP reverse shell and then add GitHub to it. Pentest Monkey is the one that we have been showing. I like using now the one from Ivan. I mean, I can pronounce that last name. But if we go there, go to the source, go to reverse, and the PHP reverse shell, this is going to be a good one to use. So we can copy this, and then let's remove that old one we copied, wget this, and let's see exactly how to use this one. So at the very bottom, it has an IP address, and we're just going to put 10.10.14.8 and change the port to be 9001. Okay. So let's now copy this. So we can cat PHP reverse shell, xclip, selection, primary, I think. I think that just put it on my clipboard. And we go back to here. Paste, let's see, selection, clipboard. I always get that wrong. There we go. So now we have pasted it. And what we want to do is change PHP so we have a capital letter. And then we can save. And it says no website has been created yet. So it looks like some type of cleanup cron came in and deleted all the websites. So let's just go ahead and quickly recreate it. So we create that. We create a page from scratch. Give it a name and alias. Then we can edit the HTML source and paste in our script. So if we do save, we probably need to listen on a port. And then let's go and click this little preview page. And since I am having it go through BurpSuite as this weird way, I have to add 8081 there, and I get a connection. It doesn't show my shell, but if I do a command, we can see it. So let's just do a standard Python 3, import pty spawn, bin bash, and then stty raw minus echo, foreground it. And then we can export term is equal to xterm. And then the last thing I want to do is just set my TTY. So let's do stty-a rows 28, columns 110, stty rows 28, columns 110. And there we go. So now we have a workable shell. The first thing I always like doing is dumping the web database. And maybe my stty did not work. Let's see. stty rows 28, columns 110. I'm not sure why that's behaving that way. It's weird. I'm doing something wrong. Not exactly sure. When I do stty-a, rows 28, columns 11. It's not actually letting me hit 0 there. What? This is bizarre. STTY rows 28 calls 110 119. Is my 0 key just not working? 0's working there. Can't hit it there. Can hit it here. I have never seen that before. Let's do columns 111. Yeah, I can hit the parenthesis, but not 0. I am at a loss for words right now. Maybe it's this reverse shell has like a bug where it just doesn't work with the 0 character. I don't know. I can't even speculate at that. That is awfully bizarre and hopefully doesn't cause an issue down the line. Okay, so let's move on. Looking at CRM, what I want to do is try to find the config, right? So if we go to HTDocs, let's see, is there a config directory? There is a conf. And inside a conf, we have a few PHP files. So if I cat conf.php, we get that. I'm going to grep-v to hide everything that begins with 2 slashes. And then I'm going to grep period to just show me, to hide all the blank lines. And right off the bat, we have the DB user, Dolibarr owner, and this password. So let's go and v creds MySQL Dolibarr owner and that password, and take note of that. And there was also a backup file, right? So let's look at the back, conf.php.old, and there is no password here. So my first step is let's log into the database. So let's go MySQL-u Dolibarr owner-p, put in that password, and then we can use probably Dolibarr as the database name. Let's do show tables. Let's describe the LLX user table, because what we want to do is dump users, right? So I see email. I see login. So probably want to get login, pass, and pass scripted. So select login, pass scripted from, what was this table name? Like XXL users, LLX user. There we go. So we have 2 hashes. Now, normally I would crack these hashes, but this doesn't really get you anything. I just want to show this is always one of the things I do when I dump a database. I would also be like, I wonder who created that Dolibarr user, right? Maybe there's a name associated with it. If we go up here, we can see first name, last name. So I'd add these to my query. And it's all just blank. It looks like it's a default super admin user. But the step is, if we look at users on the box, etc passwd, grep every line that ends with sh. We have Larissa. And if we do an su to Larissa and then use this password, we have server fun 2023, right? Did I not paste that correctly? Yeah. So that's how you get into this user. When I was initially doing the box, I didn't actually do this right away. I do want to show kind of like a rabbit hole I went down, because I think you may have went down it as well. And it will make more sense at the end of the video when we dig through the next exploit that we explored this, right? So I'm just going to SSH here, and we'll leave this session in the background. So we need to be this user. So if we ran linps, it would discover some SetUID binaries. I'm just going to run it. Oh, I can't hit 0. I can't do -4000. Let's see. Can I copy a 0? Let's see. Find perm. I can. Sweet. We need to copy 3. That is the weirdest bug. So if we do this and then we hide error messages, I don't know if it's -4000 or just 4000 to show SetUID files. I want to say it's dash. It is. So these are all SetUID files. LinPeas would call out these are unique ones that it just doesn't know about. And if we looked at enlightenment, we discover some CVEs against it. So these are very unique SetUID binaries that you normally wouldn't see on a server. I wonder if I can execute this with help and get the version. Internal tool, do not use it. Let's see. If we do a strings against this, is there like a version? That's LDSO. Let's see. dpkg-l. Sweet. Let's do grep-i enlight. So we can see enlightenment 023 is running. So if we look for CVEs against enlightenment, let's just do enlightenment exploit. We have 025-3. And let's see. This exploit really just runs these commands. These are the only ones we need to run. Let's see. This is just going to remove things. So if we ran this from the www data directory, it did not work. Didn't fail as I expected it to. Oh. Because the very first thing it does is use this find command to set something. Let's see. Where do we run strings? Oh, God. Let's see. stty rows 28 calls 11. I can't hit 0, but now I know I can copy and paste a 0. I thought I could. Can I copy and paste 2 zeros? I can't copy and paste 1, but I can copy and paste 2. That makes 0 sense. Okay. Now my terminal should be fine. So if we do -help, okay, we get that. So what this exploit is doing, we don't have to redo these steps because it's already done them. It makes tempnet, then it makes this weird directory, dev.temp ;temp exploit. And then we make the file temp exploit and make it executable. And then it runs enlightenment with all these arguments. And I know this isn't going to make much sense. It doesn't have to make sense to do the video. Like if you're just trying to follow along, like understanding the exploit is probably going to be outside of the scope since this box, I want to say, was easy, but I think it's still something you should take time and learn the exploits and see how they work, right? And if you do it enough, it will no longer be black magic. It's wrapping weird on multiple lines. I think this is right. Don't know if that comma is supposed to be there. Let's see. 1, 2, 3. I think this space here. I may just find this exploit on GitHub where it doesn't have this weird line wrapping issue. If I run this, we get action not allowed. But if I run the command as Larissa, I'm root. So one of the things that confused me is why is www data can I not exploit this, but as Larissa I can? Because my first thought was maybe like I don't have some type of permission on this, but if we look at it, the binary itself is executable by anyone. So there's some type of logic inside of this binary that only allowed Larissa to execute it. Now, spoiler, it's going to be because Larissa is a member of the ADM group, but let's take a look at exactly how this exploit works, because this just isn't satisfying to me. Like, yay, I rooted the box, but I didn't understand how it worked. So I'm going to go down the whole journey of what I did picking apart this exploit so I could learn from it. Let's go back to Google, and then we can search for Enlightenment CVE, and then find some better articles. This CVE GitHub repo is the one I had initially found when solving this box, and it's from the person that did find it. However, I don't really like their explanation of it because they went through the whole black box perspective, which it's definitely good because you normally won't come across SetUID binaries you have the source code to, or you may not. It's just harder for me to read all the decompiler output when it's available just open source, right? So if you want to, you can step through this and try to understand how they solved it. But since the exploit's already been found, we can just go and take advantage of looking at change logs, right? And I definitely always find value in doing this just because you can see how things were patched. And sometimes you'll find, oh, it wasn't patched fully and find a loophole around it, or you just learned how things work, right? And the heart of this patch is they added this function check sane path. And we can step through what this does. We have a bunch of forbidden characters. So a lot of these symbols that allow for command execution. Some of them don't. Like, I don't know why we need to blacklist the %. Maybe that's going to be like a printf thing. But they take away a lot of just characters that shouldn't belong in a path. And then over here, they're making sure the path doesn't contain 2 periods back to back, because you can't really whitelist a period because you may need it to, that's part of normal file names, but you never really need 2 periods in a row. So they just block that all together. So here they're looping through forbidden characters. And then this one is interesting. So this is going to be nothing in lower ASCII or high ASCII. So when I was first looking at sane path, I kind of just ignored this last check and was like, oh, it's going to eventually lead to a system call, and I can probably do an injection with like a line break, because that's another way to inject in the system that isn't covered here, but it is covered on this. So if the character is lower than space, but higher than 7F on the ASCII table, it's also going to return false. If we do a man ASCII, we can see exactly what that encompasses. Let's just do it on a new pane. There we go. So space is going to be right here, 32. So it's blocking all of these characters up here, right? We can't insert line breaks because that's lower than a space. And then anything higher than 7F. So we can go here, and we're blocking anything delete and above. So again, what they're doing is just saying you can only do characters between hex 21 and hex 7E. And then they also put a lot of exclusions, so you can't use dangerous special characters like the $ backticks, things like that. So it looks like a relatively good way to prevent command injection. There are still some like catch-22 scenarios, or maybe catch-22 is the wrong phrase, but you may still be able to get command injection if it's like a GTFO bin, and there's an argument that you can do to get code execution, but I don't think that's the case here. It's just things I think about, right? So now that we know the patch, I want to go and take a step back in time and just look at the exploit from or the source code 3 years ago, because this is 2022. I'll go 3 years because that's when it's vulnerable. And then we can kind of understand how it works from there. So let's see. Actually, that's not what I want. Let's just go here. Awesome. Let's look at the commit history. Then I'm going to find one that is really old so we know it's still vulnerable here. And then we can just take a step through it, right? So let's see. Browse the source at this date. And it was in source, bin, and main. So sys_main. Here we go. So this is what creates that Enlightenment DLL. So let's take a look at the exploit. Let's see, do I have it on my box somewhere? Here we go. So right at the start, I'm really curious about like these two things. So we'll look at this first. This is going to be argument 1, 2, 3, 4. I want to say this is argument 5. Well, not that. Okay. Is there a 6? Nope. Okay. So I'm just looking for argv5 because that's going to be where the code pulls this very last argument, and we can kind of just examine how that works. Like, why do they have these 3 slashes? That's really odd. So here we're assigning the last argument to MP, and then we're running stat on media. So you're making sure that directory exists. Is that needed? So that's not important. Okay, I don't think any of that is important there. Okay, right here. This is where we're going. This strchar is going to get the string at the last occurrence of this. So we're going to get the string right here on /net. So that's what node is going to be equal to. So if there's no slashes, if we're just not there, return false. I don't know exactly what this one is doing. If node 1, I wonder if this is the character. Oh, this is if it's a directory. So this is saying if the very last character is a slash, then return false. That would be my guess. And then right here, what we're doing is calculating the space between the last slash and the start of the string. And if it's not 6, return false. And this piece is really odd. I think it's expecting the path to be media, because here's the example of the arguments. It looks very similar to our arguments like the -o, and then UUID here. We don't use UID, we use dev. But then afterwards, they're doing media. And if we look at this, media, 1, 2, 3, 4, 5, 6. So for some reason, they're not saying if string starts with /media. They're just saying if the space between the last slash and the start of the string is not 6, then return false. I don't know exactly why they do starts with media. Maybe it's a case sensitivity thing. No idea. But if we look here, 1, 2, 3, 4, 5, 6. So all this is doing is making that path look like it was /media to the check, right? Because it gets the string here, and that's looking back 6. Really, really odd. Not sure why. Maybe someone in the comments knows. And then we're going to create a new string, and we're going to do /dev, and then whatever's after the last slash. So that creates a new string devnet, and it's doing a stat on that and says, oh, devnet exists. We have now passed that check. So this is a really hacky way to just pass the check. Here's another weird instance of oddity. So let's look at this. We're looking at where we load argv4 in. So if it begins with UUID, we're going to do this stuff. We don't begin with UUID. We begin with a /dev, right? /dev right here. So we go down this path. And then we're going to do a stat and make sure it exists. So it's doing stat against this string. And this actually exists because if we go back to the exploit, let's see, where is it? We actually make that directory. We make dir. I don't know why they do /dev ... /temp. You could just do make dir /temp and then semicolon whatever. So semicolon is a valid character for a directory. So if I went back to the box and we go to /temp, we do see a semicolon directory. So I'm going to escape and go into cd semicolon. Then we got temp, and then we got exploit. So this weird path, where is it? This weird path, when it does a stat, actually passes. It's hard-coded to look for things in dev, and they just assume you can't write to things in dev, but we can. Now, the semicolon is important. Like, why is that there? Because eventually that will get passed all the way down into this system call right here. Let's see what this is doing. So if everything passes, it's going to loop through every argument and then create a big buffer and then do a system command against that, right? So all it's doing is running system against this whole string. And since we managed to inject the semicolon here, this is where we do the command injection, and the system goes, okay, I'm going to execute temp exploit, which we created as a file beforehand. And that's what led us to get our shell, right? Because if we look back at the exploit, right here, we echo bin sh to temp exploit and make it executable. So a lot of this stuff is just oddities in order to get the code execution. Now the question becomes, why couldn't we execute this as dub data? Why did we have to use Larissa, right? I said the spoiler was because Larissa was a member of the group, but let's go take a look at that, right? So let's see. Let's go back into the source code, and we're going to step through things from the beginning to understand exactly how this program works. So here's the main function. Right here, we're comparing, let's see, all the arguments. So we're looping through them. And if any are help or H, we're just going to say this is an internal tool, go away. Let's see, over here, if the first argument is T, then maybe we're going into test mode. Not exactly sure there. Oh, this is not -T. Not sure. I'm going to go through this quickly, so sorry if I don't get everything this code is doing. Let's see. Right here, we're getting the first argument and the last occurrence of slash. So what is this? Okay, so the first argument /bin/mount. So we're going to grab the string right here at slash. And then if there is no slash, we're going to error. If it ends with the slash, then we're also going to error. Well, we're going to exit if there is no slash and it ends in a slash. So that's what that's doing. And then we're going to move up one character. So we were right here. Now we're going to move up. And then we're going to see if the leftover is mount, umount, or exit. And then we're going to move on and set that as our action. So our action is going to be mount. So we keep going. We're going to set our UID, GID, effective. Right here, we're getting groups. And if we have more than 65,536 groups, we're going to error. I'm going to guess this is going to be some type of like integer overflow type of exploit. I don't know what they're preventing there, but that's my guess. I don't even know why you'd ever be a member of 65,000 groups. That is definitely a lot. Right here, if our SetUID call fails, so if the binary isn't going to be SetUIDable, then we're going to say, oh, we can't escalate the privileges. That's fine. And then we get to this auth action. So auth action, okay, this is probably going to be where we want, because when we were dub data, this is the exact error message we got, action not allowed, and then it said mount. So let's look at action auth. So here we're going to get PWUID. I don't know what PWUID stands for. Get PWUID, searches the user database for an entry with a matching. So we're getting the information about the user matching the UID, and we called it, I can't scroll up easily, but this is going to be the UID of the user, because before we hit this, we specified it as a variable, right? I'm assuming yes. So looks like we're just doing a lot of things here. I'm assuming just from glancing at this is looping through every single group and just building like a list of the groups that we're a member of, right? So all this code is just building information about a user. And then we're going to call this auth etsy alignment sys actions. So let's look at this. This is another function. Looks like we're going to probably read this file. It can either be an etsy or slash. Let's take a look at what this file looks like. And if we look down here, we can see the structure of lines, what it should be, but let's just look at the file. Let's go here. We can cat this, and we see how it works. Like user, root, allow anything, group, operator, staff, admin. So this is what we're allowing. And then at the very bottom, user, star, deny. So if there is no allow for a current user, then it's going to get denied. And ADM is a group. If we look at the groups of Larissa, she is an ADM. So that's why she can call this binary. So we go here, we're doing gets, and over here it's comparing. And let's see, one of these will return true. So if it ever hits a allow, then the function exits, returning true. So that is why www.data couldn't use enlightenments for privesc, but Larissa could. Let's see, is there anything else we want to talk about in this exploit? I don't think so. I think that pretty much covers it. So hope you enjoyed the end of the video. It's probably more complex than what you need for this box. I know it's definitely more complex than what you need for the box, but hopefully you enjoyed it anyways. Take care, and I will see you all next time.